Hello and welcome back to the deep dive. It is great to have you with us today. I was staring at my phone this morning looking at a notification, and the headline just said AI,
Just the two letters?
just AI. And it really hit me. We use that term like it's a single thing,
Yeah.
like it's a toaster.
Or a specific person, yeah. It's the ultimate buzzword right now.
It is. It feels like this giant sort of shapeless monolith that we just throw into sentences.
And you're right, treating it like a monolith is where a lot of people get tripped up. It's like talking about physics.
Oh, that's a good analogy.
I mean, if you just say physics, are you talking about gravity?
Yeah.
Or thermodynamics?
Hmm.
Or quantum mechanics? AI is just the umbrella, the real magic, the interesting stuff happens when you look underneath.
Exactly. And that is why I am genuinely excited to dig into this specific document today. We're working off a breakdown titled Day 7 AI Branches Overview. And what I love about it is that it's like a butcher's diagram for that monolith. It slices the whole concept up so we can actually see the ingredients.
It's a very necessary dissection. So the material, it identifies 3 core branches that really make up the whole ecosystem.
Okay.
Natural language processing, computer vision, and robotics. And our mission for this deep dive is to understand not just what they are. I mean, you can Google a definition.
Right.
But how they actually function and, more importantly, why they're distinct from one another.
Right. We want to move from, AI does stuff to this specific mechanism enables this specific action. So let's unpack this. The first branch the document highlights is one I think we're all maybe a little too intimate with, especially if you've ever shouted at a smart speaker.
Oh, yes.
It's natural language processing, or NLP.
NLP. The voice and brain of the operation, really. The text defines it as the branch that enables machines to both understand and generate human language.
And I think we need to pause on those two words, understand and generate.
Yes.
Because those feel like two wildly different hurdles for a computer to jump over.
They absolutely are.
Yeah, let's break that down, because understanding feels, I don't know, almost philosophical. I mean, does my GPS really understand me when I say an address?
Well, that is the big question.
Yeah.
In the context of NLP here, understanding is really about parsing intent. Language is messy.
So messy.
It's full of idioms, slang, sarcasm. If you say, great job, genius, to a friend who just dropped something.
Right, they know you don't mean it.
Exactly. A human gets the sarcasm. A basic computer just hears, great job, and genius, and logs it as a compliment. NLP is trying to bridge that exact gap.
Okay, so the document lists examples like Siri and Alexa. When I ask Alexa to play a song, it has to cut through my accent, the dishwasher in the background, and figure out that play is a command.
A 7 overview also highlights the output side, the generation part, and it explicitly mentions ChatGPT.
Of course.
This is where the field has just exploded. It's not just pulling up a pre-recorded answer. It is constructing sentences, from scratch.
That distinction is huge. It's the difference between a librarian handing you a book that already exists.
And a librarian writing you a new book on the spot.
Yes, that's a perfect analogy.
And because it's generating, it can mimic flow and tone. But the document points out 2 other capabilities of NLP that go beyond just chatting, and I think these are super important.
Okay.
One is text summarization, and the other is sentiment analysis.
Text summarization seems pretty straightforward. Take a long report, give me the short version. But sentiment analysis, that sounds a bit like mind reading. The text says it allows machines to detect the mood behind words.
Yeah, think about it from a business angle. You launch a new product, you get 10,000 tweets about it. You can't read them all.
No way.
Sentiment analysis scans them not just for keywords, but for the vibe.
Yeah.
Is the customer angry? Are they happy? Disappointed? It's basically assigning an emotional score to text.
So it's trying to quantify emotion. That feels incredibly hard. Humans use irony, double negatives.
It is difficult. It's one of the hardest parts of NLP, for sure. But when it works, it's so powerful. A machine can say, hey, 80% of the people talking about your brand today are angry, without a single human having to read a post.
So if we step back, NLP is basically the interface layer.
Precisely.
It's how we get information out of our heads and into the machine without having to, learn code.
It's the bridge. It humanizes the whole interaction. Without it, we're back to punch cards.
Okay, so we have the voice in the brain. We can talk to the machine and it can talk back. But right now, it's just a voice in a dark room. It's blind. Which brings us to the second branch in the overview. Computer vision.
The eyes.
The eyes. The definition here is that computer vision lets systems interpret and analyze visual data. And again, I want to push on that definition a bit.
Okay.
Cameras have been around forever. My old camcorder could analyze visual data in that it recorded it. What's the leap here?
The leap is in that one word,
Mm-hmm.
interpret. A camera just records pixels. It doesn't know what those pixels mean.
It's just a grid of colors.
Right. To a normal camera, a picture of a cat is just a bunch of orange here, some white there. Computer vision is the software that looks at that grid and says, that is a cat.
It's moving from just capturing an image to actually recognizing what's in it. The doc mentions face and object recognition.
Right. And we see this on our phones all the time.
Yeah.
You take a photo and your phone draws a little box around someone's face.
Yeah.
That's computer vision. It's identifying a pattern that looks like a human face among all the chaos of the background.
And it's gotten scarily good. I can search my photo library for beach, and it finds every photo I've taken near sand. I never tagged any of them.
That's object recognition.
Yeah.
It understands the visual texture of sand, of water. But there's another function listed here that I think is the unsung hero of the modern office. OCR.
Oh, optical character recognition, absolutely.
Yes.
This is when I take a picture of a document, and suddenly I can copy and paste the text.
That's it. The text explains it as machines literally reading text inside of images. And it's not just matching shapes. Modern OCR uses a little bit of that NLP we just talked about.
Oh, interesting.
It uses context to guess blurry letters. It's reading in a very human-like way.
So these branches don't really stay in their own lanes, do they? They start to bleed into each other.
Not at all. They're constantly borrowing from each other.
But where computer vision really hits the road, literally, is in the applications, the document lists. It brings up self-driving cars and medical imaging.
And the stakes there are exponentially higher than just sorting my vacation photo.
Much higher. Let's take the self-driving car. That is arguably the ultimate test of computer vision.
It really is.
The car is going, what, 60 miles per hour? It has to identify a stop sign, a pedestrian, another car, a plastic bag drifting across the road.
And it has to do it instantly.
Yeah.
And it has to know the difference between a real person and a picture of a person on a billboard.
Exactly. It has to interpret depth and intent. I mean, if it sees a ball roll into the street.
A really advanced system might predict a child could follow that ball. That's interpretation, not just recording. It's predicting the future based on what it sees.
That's just mind-bending. And then on the other side, you have medical imaging.
This is where computer vision becomes a real partner to people. A radiologist might look at 100 x-rays in a day. Fatigue is real.
Of course.
But a computer vision system can look at 1,000,000 x-rays and never get tired. It can spot tiny anomalies, a little shadow on a lung, a microfracture that a human eye might just gloss over.
So it's not replacing the doctor.
Not at all. It's giving them a superpower, a second set of eyes that never blinks. It just highlights an area and says, hey, doctor, look closer right here.
It's augmenting human ability. Okay, so we've given the machine a voice with NLP. We've given it eyes with computer vision. But so far, this AI we're building is kind of trapped in a box.
It's a brain in a jar.
A brain in a jar with a camera on it, maybe. To actually affect the world, it needs a body. And that's the third branch, robotics.
And now we enter the physical realm. The source defines robotics as the integration of AI with physical machines.
I like that word integration, because a robot without AI is just, what, a remote-controlled car?
Or a clockwork toy, yeah.
Yeah.
It moves, but it doesn't react. It's not intelligent. Robotics, in this context, is about the machine sensing its environment and making its own decisions about how to move. The text says autonomous physical tasks.
Autonomous, that's the key word.
It is.
So it's not me with a joystick telling it what to do. It's the machine deciding, I need to move this arm 3 inches to the left.
And doing it while dealing with gravity and friction and unexpected obstacles. People often underestimate how hard robotics is compared to the purely digital stuff.
How so?
Well, in a computer, code is perfect. It's clean. In the real world, wheels slip, gears grind, things are heavier than they look. Robotics is where the perfect logic of AI crashes into the messy reality of physics.
The document breaks down the use cases into factories and logistics versus healthcare, and those feel like two ends of a really wide spectrum.
They are. In factories, think of those giant warehouses. You have what the text calls industrial robots. These are all about brute strength and speed.
Picking up a heavy box, welding a car door.
Exactly. Reliability is the name of the game.
Yeah.
Doing the same motion 10,000 times without getting tired and without complaining.
Automation of labor.
Right. But then you look at the healthcare example. Surgical robots. This just flips the script completely. It's not about strength. It's about superhuman delicacy.
I've seen videos of these. They can stitch a grape back together.
It's unbelievable.
Uh-huh.
A surgeon controls the robot, but the robot filters out the tiny natural tremors in the human hand. It allows for movements that are smaller and more precise than any human could physically manage on their own.
So in the factory, the robot is the muscle. In surgery, the robot is the fine-tuner.
That's a great way to put it. But in both cases, it fits that core definition. AI interacting with the physical world. It's the body of the system.
And that completes the triad. You've got the brain and voice with NLP, the eyes with computer vision, and the body with robotics.
The full suite.
It's a really clean way to organize it, but I do want to push back a little on how neat it all is. The document presents these as separate branches, but in the real world, are they really that separate?
That is the so what of this whole deep dive, isn't it? Historically, they were separate fields. You had linguists working on NLP,
Yeah.
optical engineers on vision, mechanical engineers on robotics.
They were in different buildings on the university campus.
Exactly. They didn't talk to each other much. But look at the examples we just used.
Yeah.
Take that self-driving car again.
Okay.
The document lists it under computer vision. But a car is a physical machine. It has wheels, it has a steering wheel. That's robotics. And if I get in and say, take me to the nearest coffee shop.
You're using NLP, so the car is actually all three.
It's all three. It's a rolling synthesis of the entire document.
Yeah.
And that's where the future of this stuff lies. It's not in these branches getting better in isolation. It's in the convergence.
Right.
A robot in a factory is useful, sure, but a robot that can see a dropped part with its vision, understand a worker shouting, stop, with NLP, and then physically halt its own arm using robotics, that is a completely different level of technology.
It brings it all back to that kind of synthetic human idea. We're slowly assembling the pieces of a complete sensory and physical system.
We're giving the system senses. We're moving from just being calculators to being agents. An agent can perceive, think, and act. And that's what the combination of these three branches enables.
It's a little bit exhilarating and also a little terrifying, depending on the movie you just watched.
It is. But understanding that these are the components helps demystify it a little. When you see a smart robot, you can look at it and say, okay, that camera is the vision part, that speaker is the NLP part, and the motors are the robotics part.
It stops being magic and starts being engineering.
Exactly.
And that's exactly what we wanted to achieve today, to take that big, shapeless AI monolith and break it down into parts we can actually name and understand.
And hopefully we've managed to do that.
So before we go, I want to leave everyone with one final thought to mull over. We talked about how these branches are converging. The document outlines them as distinct: voice, vision, body.
Right.
But if you think about how humans learn, we don't learn language in a vacuum. A child learns the word ball by seeing a ball and by throwing a ball.
That's a profound point. It's called embodied cognition.
Exactly. So my question for you and for everyone listening is this. Can AI ever truly understand language, the NLP part, if it doesn't have a body, the robotics part, to experience the world? Or eyes to see it? Can you really separate the brain from the body and expect it to work?
That is the billion-dollar question that researchers are wrestling with right now. Does real intelligence actually require a body?
Something to think about the next time you ask Siri to turn on the lights. She can do it, but she doesn't know what light actually is.
She's never actually seen the sun.
On that slightly poetic note, we're going to wrap up this deep dive. Thank you for listening, and thank you for helping us dismantle the monolith.
Always a pleasure.
Keep your eyes open for these three branches. Once you know what to look for, you will see them absolutely everywhere. We'll see you on the next deep dive.